Still shielding it over it because these bang hermetic capacitors make me nervous. I don't want to lose an eye, and I can't bother to go out and get my safety goggles. Got to be careful here. So that's from the computer supply, and this is the output on my side. 5.1 hits. Holy shit! It works, boys and girls. I've done it! No transformers, no fucking switch mode, fucking high frequency shite. We've got a fucking power supply. Now all I have to do is measure the current that goes in and comes out. And then we can calculate the efficiency. I'll leave it run a few minutes, we'll see if it gets warm. That fan's pulling close to 5 watts. I want to try this. You're going to think I'm cheating because it's really close, but that's our reference voltage. I'm just using that as a computer power supply is generating the reference. If we were regulating it with the transistor like in the clock, or really what the 7805 does internally, the transistor would get really hot, and by now we'd be dissipating like, let's see, 7-8 watts through that one over there, and it is stern cold to the touch. It's absolutely freezing because we're passing 12 volts. Your only drop is the 0.7 volts for the silicon. Like, it is transistor, we're using them as SCRs. You know, you just put them as a PN pair. This might actually work. I might have just fucking completely broken the power supply market if I can get this to go. That is... Honestly, I thought something would go wrong. It seems to have worked first time. I don't know if the little transistors that control it are getting hot. I'll have to have a look, because the conditions do exist where when those fire, they could actually pull the whole fucking incoming supply down to ground. And it shouldn't happen, but if one of them starts going a bit slow with temperature, it could sort of, for just a split second, get that bang, and it could blow itself to bits. Don't mind the mess. I had no point clearing up while I was doing this. You know, I'll get to it now. I've done, but that's nuts, and it's still regulating, and it's still cold. It is really cold. So at the very least, it's more efficient than just a plain linear regulator. That is, to say it's running out of spec and everything, that is crazy. Now I have to test it out and see what happens, you know, with overload and underload and how it'll behave. If we underload it, it should, the sort of dimmer LED at the back should just sort of come full on, and that should be the system. Basically, it just deadlocks sort of off and can't really run. Overload, I don't know what it'll do. I imagine you just burn the transistor out, but you know, the SCR, you put an SCR in it, but they're expensive, and these are just shit Chinese transistors that I bought, so they're probably not even very good. It's cold. I'll get my temperature gun for you. We'll have a look. As I say, if we were dissipating, if it was just, because it should self-latch, because the transistor will get something there, the reference voltage. Let's use the top of the tab there, 23 degrees, 21 degrees. So that one is warming up, but that figures because that's passing all the power. And we're about that temperature in here. So yeah, 23 degrees. 21 degrees. That one's actually colder than room temperature, which is probably just the aluminum. The ones underneath don't seem to be getting very hot either, those control transistors. That's nuts. I didn't think it'd work yet. I've just built a power supply that is... yeah. Well, now we know the concept works. Let's build a big one, see if we can run an AMD Athlon with it. That'll be fun, won't it? Because that was the original intention, was to just run it off a PC power supply to use with like Athlons and Pentium 3s and early P4s, and that might just be attainable. Really, it's the same exact circuit, just need to stick bigger transistors in it. It should be good to go. Of course, this strip board's only good for a set amount of current before it melts, but yeah, damn. That's absolutely crazy. Absolutely crazy. But I'll tell you what I'll do, just to, because I know something someone else is going to doubt, especially with the voltage being dead on reference, which I thought it'd sell a little bit high. I was like, I've missed a few components here to keep it stable. But what I'll do, let's unplug this, put the meter in continuity mode. So there you go, it's continuity. We go for 5 volts on there, and we go for my output. And what do you know? No continuity. I'm not cheating and just getting power from the power supply. Because someone's probably going to sit there and be like, oh, he's cheating. I'll even take that off. But nothing. Completely open circuit there, because that is... the only place that goes is that comparator there. It's the only place that 5 volt goes, and you know, on the big ones we'd generate that on this board, but for the application this one's for, there's no point, because we just take it off that, you know, which, like I say, was the original intention of doing that. That it's just sort of tepid, just slightly above room temperature on that one, but that's the one that all the power gets dropped through. So, yeah, that's insane.